Raise your hand if you're done. Raise your hand if you need like 30 more seconds. Okay, keep at it, keep at it. So here's my solution. And sometimes this is, you know, I notice year after year, this seems to be one of those problems that people who have been doing really well, understood everything, where people start to struggle. But it's because they start to get their heads stuck thinking, well, that's like, with a while loop, you just have a counter. No, a while loop, you just have a condition. Well, why did I need two variables? Because I wanted two variables. I could just have two variables. I wanted one to keep track of what's the current integer, and I wanted one to keep track of the running total. But some students will think like, well, how was I supposed to know to have two variables? You weren't supposed to know you needed two variables. You were supposed to just solve the problem, and I decided I wanted two variables to do it. Remember, when you're programming, you're God in your world here. If you want another variable that does nothing, go ahead and add it. It doesn't matter. You can do whatever the hell you want. I mean, obviously, it's not going to make particularly good code if you're doing stuff like that. But there, I had two variables. One to keep track of the current int, and one to keep track of the running total. Well, current int is less than or equal to n, because I want to include n. Add the current int to the running total. Then increment the current int. And then when the loop's done, return the running total. And that looks right. 1 plus 2 plus 3 plus 4 plus 5, I'm pretty sure is 15. So that looks pretty good. Did anyone do it wildly different?
Not wildly different, but instead of counting up from 0, counted down from n.
You counted down from n, entirely fine. So you said n plus n minus 1 plus n, it's like 5 plus 4 plus 3 plus 2 plus 1. Nice. Anyone else do it a little different? Now you got to be careful with edge cases here, because some people might think to themselves, well, you know, start at like 1, right? Like why bother starting at 0? But what would happen if I did this? What? Okay, so running total's there. Okay, so that's fine. I guess we could start that there. And then really we could start that at 2. Let's see if that still works, right? All right, that still works. But what happens if I start at 0? Yeah. What I'm trying to show you here is you may have thought to yourself, well, I mean, there's no sense of adding 0, right? 0 is just not really there. But okay, fine, but you got to be careful how you go about doing it, because if you did something like what I did here, where I'm trying to skip 0, well, what happens if I ask what the sum of all the numbers between 0 and 0 is inclusively? Well, if I'm not careful, I might mess up my edge case. Edge case meaning like what happens at the edge of the valid possible things, right? -1 doesn't really make any sense in this context. 5, I mean, clearly we see 5 works. But when I asked 0, it didn't work in this case. So we got to be careful, just be aware. People asked after the test, the course doesn't get harder. I mean, it does, but like the curve of difficulty increase is relatively, stable, I would say. There's no like big jump in what you need to do to understand the concepts we're learning. It's more difficult, today is more difficult than yesterday just because we know more and we're always building on top of what we know. But where the difficulty people find, and this is absolutely 100, like I agree with this makes perfect sense to me, where people find the difficulty is not loops. They don't find loops difficult. None of the individual tools we're learning are going to be overly crazy difficult. That doesn't mean they're trivial. That doesn't mean you should look at a loop and immediately understand it like that. No. I just mean, in and of itself, that's not where the complexity is. Where things get challenging for new programmers is how to use this with other variables and ifs and else's. And as you start to use more tools at once to solve problems, that's where things get difficult. But one of the big tricks I find is stop trying to be so smart. Programmers are dumb. If you're trying to solve a problem by going at it saying like, I've got all these tools, how am I going to use all these tools to solve this problem? You're trying to do too much at once. Slow it down. Every problem is some collection of smaller problems until you get to some like atomic problem, like add one. Okay, I can do that, right? But if I'm asking you to sum up all the numbers, and you're thinking, oh man, how am I supposed to? No, slow down. What parts do you need? Okay, obviously I know I'm going to need a loop to go over like 0 to 1 to 2 to 3 to 4 to 5. Do that. Then what? Then you go, what else do I need? Okay, I'm going to need another variable maybe to keep track of some running total. Okay, do that then. I could add an if statement in here and be like, if it's a multiple of 3, don't add it though. Right? So maybe I told you add up all the integers from 0 to n inclusively, but skip any multiple of 3, right? Okay, well, to do that, I would need an if. If you're trying to go about this going like, I need an if, I need a while, I need a this to solve this problem, stop it. You're working too hard. You're making things way too difficult for yourself. No programmer in their right mind is capable of doing that much complexity at once. Break the problem down. And now, I'm not saying this to be like, oh, just break it down. No, that's a skill you have to learn. That's a skill you're developing in this course. You're not supposed to know immediately how to do it, and there's no way I can show you the steps to properly break down a problem. No, that's just a skill that you need to develop. You're going to develop that intuition. This is where it's more of an art than a science. And you got to develop these skills through practice. Break the problem down into something you can solve with a simple tool. Then what do you do with that? Well, I've solved that problem, and now I can do a bigger problem with another simple tool, etc. Just don't make life too hard for yourself. Keep it simple. Solve the simple problems, and next thing you know, you've solved the big problem. All right. Forget that one. So the functions. So did anyone else, did anyone do int sum a little differently? No? I mean, there's a bunch of ways we could have done it. But this right here is an example of an algorithm. An algorithm is just a fancy, more mathematical way to say a recipe. Follow these directions, and if you do, you're going to end up like given this, and if you follow those instructions, you get that. Given the ingredients, I follow the recipe, I get a cake. Given that, I give it an integer, I get back the sum of all the integers between 0 and n, the integer I gave it. That's an algorithm. Now, obviously, the code and the algorithm are very connected here, right? You're looking at the algorithm right there, but algorithms and code are ultimately independent from one another. I could implement the same algorithm with wildly different code. So The code is an algorithm, but we'll see more examples of this as we go, but I've been saying it a bunch along the way. You know, I always like to ask, did anyone do it a little differently? Well, you counted backwards, right? So yeah, your algorithm was actually a little bit different, but it did the same thing. So that is an example of a different algorithm, similar, but it was a little bit different, but it solved the same problem. Sometimes we can have the exact same algorithm, but code it really differently. The code isn't the algorithm. The code is a manifestation, a representation of an algorithm, but we can say the same thing in a different way. How I can explain to you in English how to sum up the numbers between 0 and n inclusively, and that's an algorithm. It doesn't have to be in Python. Yeah, all right. So yeah, here, just as another exercise to kill some time, write down in English, or explain to someone next to you if you're sitting next to somebody, the step-by-step. Don't just say it all at once. Break it down like step-by-step instructions so it's easy for your grandma to follow. How would you sum up all of the even numbers between 0 and n? All right? Write that down step by step, or talk to each other about how you're going to do it. And then once you've done that, once you're convinced you have it, write it in Python. And then compare your Python code to the algorithm. Do that. If you're saying it to the person next to you, you don't have to whisper. Just everyone else is being quiet because you're being quiet. Jesus Christ. Here's my implementation. And I wrote above it in the comments, like my English algorithm. Whose English algorithm is more or less what I have there? Yeah. I mean, hell, you even look at this and you start to realize it's not even that different from the code itself. Here, I can even like write it more like the code by indenting. Right? And suddenly it looks a lot like the code itself. I mean, the big difference here is I just said from 0, look at all integers from 0 to n. So obviously I didn't explain the details of a while loop, but it didn't really matter. I just needed a way to loop. So I have a running total. This while with the check and the current int and incrementing the current int, which I totally forgot when I wrote it the first time, and it obviously didn't work, incrementing it. That's just part of the loop. Does anyone look wildly different than this one? No? I mean, you probably could have used the int sum one as a good basis of what to do here. You just really needed to add an if statement to it. Now, one thing I want to make sure is pretty clear is a common mistake is some people would say, ooh, else, add one. First and foremost, if you have an if, you don't necessarily need an else. Sometimes I see a lot of people, they'll come to student hours and they'll show me their code, and then there's an if that makes perfect sense. But then they add an else with a bunch of nonsense in it because they just, if I have an if, I want an else. No, you only need an else if you want to do this or that. If is just, if some condition, do something. Otherwise, it doesn't matter. So don't always immediately go to an else. But obviously, this code is going to be a problem. And if you're not clear on why the code is the problem, you're trying to skip some steps. There's no trick to this. There's no hidden mystery to this code. Remember, programmers are stupid. It's what does the code say? And the reason this wouldn't work is, well, let me hit run and show you the problem. Okay, it's running. It's been running for 4 seconds, 5 seconds, 6 seconds, 7 seconds, 8. And what's the problem? Well, what does the code say? I started at 0, current int is 0. Is 0 less than or equal to n? True. Is current int divided by 2 equal to 0? Well, divided by 2 remainder, is its remainder equal to 0? Is 0 divided by 2 is 0, remainder 0, so that's true. We add 0 to the running total. Then we go back up and we ask, hey, is current int less than n? And it is, because we left current int alone. Current int never changed if it's divisible by 2. This is going to be a big issue. So the solution here is, it's not that I want to either add something to running total or increment the current int. No, it's if the number is divisible by 2, add it to the running total. And then no matter what, increment current int. We have to increment current int whether the number is even or odd. It doesn't matter. I still have to increment that thing. So this is just a warning for That mistake usually happens when people have this urge to add an else. No, if you add an if, fine, but you don't necessarily need an else. Don't jump to writing an else unless it makes sense. A single if means if I'm following along, I'm executing my code, and then I check something, and maybe I need to do something special, and then I carry on. If an else is I get to a fork in the road, and I have to do one of two things before I carry on. And this is also true for the elifs, where you have as many. Instead of one of two things, it's one of several things. But I have to do at least one of those things, and only one of those things. But a single if might be a quick little detour. As soon as you add an else, there's a fork in the road, and we have to make a decision. Any questions about any of that? All right, cool. So we've seen a couple of types so far. Strings. We've also seen integers, we've seen floats, we've seen booleans. In other programming languages, there's other types as well, and there's more types that we will learn about here. We can even make our own types. But some of those types, you know, in other programming languages, it's common to have another type where you have an individual character. In Python, you don't really have individual characters. You just have strings that are single characters. But in other programming languages, you have strings, but then you can have a type that's an individual character. And all it will ever store is a single character. You can't have more than one character in there. Regardless, if I have an integer, you know, traditionally speaking, and the reason I say traditionally speaking is a lot of modern programming languages and the way computers work now have a lot of fancy engineering tricks in them. But traditionally speaking, you know, your computer has a whole bunch of little logic gates on it that store high voltages and low voltages that get decoded into zeros and ones that mean something. And there's a finite amount of space. And when your computer gets an integer, your computer goes, okay, traditionally speaking, I'm going to use 8 bytes. No, 8? No, 4, how many is it? Whatever, let's say for the sake of argument, I can't remember right now, I'm forgetting it, but let's say for the sake of argument, your computer wants to use 8 bytes to store an integer, okay? For those of you that don't know, a single bit is a binary number, okay? But it's one digit only, all right? But what's interesting about a binary number, unlike what we're used to in decimal, how many unique symbols do we have for a single digit in decimal? This isn't a trick question. How many unique symbols do we have? 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 unique symbols. So I can actually represent 10 unique values. With a bit, it's different. With a single digit, a single bit, how many symbols do we have? Does anyone know? 2, 0, 1. So you can actually only represent 2 unique values with a single bit, which is sometimes great. If you have a Boolean, all right, 0 is false, 1 is true. A single bit can actually represent a Boolean. That's cool. But as soon as I want to store an integer, obviously a single bit's not going to be very helpful because, well, I can only store 0 or 1. What if I want to store 2? Oh, you're out of luck. Well, no. So you add another bit, right? So suddenly I can have 0, 0, 0, 1, 1, 0, or 1, 1. I can represent 0, 1, 2, 3. Yeah, with all those combinations. Every bit you add, you actually double the amount of things you can represent. So 3 bits, I can suddenly represent 8 different numbers. 4 bits, 16. 5, 32. As a neat little thing, what's the biggest number you can count to on your fingers? Easily. 10. Who told you it was 10? You've been limiting yourself your whole life. No, you're counting entirely wrong. Anyone who said it, I'm not picking on you. It's just I wanted somebody to say 10. No, you count in binary on your fingers and you can count way higher. Right? So look, let me show you real quick here. 0, 1. So far so good, right? Now, this is 2. 3. No, I apologize for this. 4, 5, 6, 7, 8. I'm having a hard time here. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. I can go to 32. So I can actually get to 32. I could get to 63, right? 127. And you guess what I could get to next? 255. Yeah? Does anyone not see the pattern? No? 511, yeah. What comes next? 1023. It's doubling it in minus 1, yeah. So I can count to over 1,000 on 10 fingers. If I count in binary, which is way better. Way better. Anyways, a single bit can store 2 values. 2 bits can store 4 values. 3 bits, 8 values, because you got to include 0. Because 0 is a value. So if I can represent 0 through 3 with 2 bits, I can represent the values 0, 1, 2, 3. That's 4 separate values. Anyways. Traditionally speaking, maybe we want to store, okay, I want to store an integer on my computer. How much room do I need? There's some amount of transistors. There's an amount of literally physical space this integer has to take up. So I'm going to store it in 8 bits. Okay? And let's say, for the sake of argument, this is 1 chair represents 8 bits. Oh, pardon me, sorry, 8 bits, 8 bytes. For those of you that don't know, 1 bit is 1 bit. 1 byte is 8 bits. Just because. So if I have 8 bytes, that's actually 8 times 8. That's 64 bits. FYI. But 1 chair represents 8 bytes, 64 bits, because I can store an integer in there. I can store a float in there, easy. I can store an individual character in there, easy. I can store a float, a Boolean, whatever. I can store a lot of values in 8 bytes, nice and easy. They fit there really nicely. If you say, so now it's interesting because realistically, you want to know how many unique values I can store with 64 bits? I can actually store 1.8 times 10 to the 19 unique values. But what if I want to store a number that's bigger than that? Well, okay, your modern computers and even older computers had ways around of doing that, ways around it. But usually people are dealing with numbers that are way less than that, right? So it's good enough for most cases. We can get around it if we need to, but for most cases, I can store an integer in a single seat really nicely. Does this make sense so far? Raise your hand if you have any questions, because next, it's very important that you understand what I'm saying so far before I get to the next thing. So if there's any questions at all, ask. Remember, if you have a question but you're afraid to ask, chances are half the people in the room have the same question, but they're all afraid to ask. So be the hero and ask the question. Everyone's happy so far. All right, cool. Now I want to be clear, I'm talking about this very abstractly, high level. If there's someone in the room that's going well, actually, the computers actually work look, I know. But that's not relevant right now. We're talking, this is how we can think about it. The problem I have is strings. Because strings are a little different. A string isn't a single character. How much room do I need for a string? The problem here is a single string. Like, how long is a string? Does anyone know how long a string can be? I don't. I could have a string that's length 0. I could have a string that has 5 letters in it. I could have a string that has 110 letters in it. Right? So, how long is a string? How many seats do I need to store a string? Like, classically speaking, I need 1 seat for an individual character in this hypothetical world. I need 1 seat for an individual character. So obviously, if I have 10 characters, I can't shove 10 characters into a single seat. There's not enough room. If I ask 10 people, if each of you is an individual character that makes up the string hello world, and I tell you all sit in that 1 seat, you're going to go, there's no space. I can't do that. You all need your own seat. So strings are actually a little funny. They're a little different. Each character can be in a seat. That's how we get around this issue of, well, how much room do I need? Well, I don't know, but I'll just take as many seats as I need for the string. I'll use as much room as I need. Traditionally speaking, this is where we start to draw the line between what we call like a primitive type. These are types that, now to be clear, in Python, this really doesn't have the same meaning. It does, but the way it works is quite different in Python. But primitive types are the things where, like, I know how much room I need for a bit. I know how much room I need for a Boolean. I know how much room I need for a character, an integer, a float. All of these things are primitive types. And they're actually all encoded with zeros and ones. But it all depends on how we decode the zeros and ones. If I have a string of zeros and ones, if I have 8 zeros and ones, and I tell you, what is this? The question you have to ask is like, well, what am I decoding it to? Am I decoding it to an integer? Or is that supposed to be a character? Anyways, primitive types, they're a thing. But then once we start to get to more complex things like a string, it's a little different. They're not primitive types anymore. And here's something interesting about a string that I've seen a lot of people do in lab by accident, is I could take the string, here. Hello world, and I can actually index the string to get the individual characters out of the string. So the string is hello world, and I say, what's the string at index 0? And remember, computer scientists start counting at 0. And there's a reason for it. It's because we're not really, that 0 for the index is how many, it's an offset, right? If I say go to the beginning of the string and take 0 steps, where are you? You're still at the beginning. So I say go to the string hello world and take 0 steps from the beginning. Where are you? You're at the letter capital H. What's at index 4? Okay, 0, 1, 2, 3, 4. Well, that's an O. It gets printed out. So I can actually get from the string individual characters. Cool. Yeah. So here's a quick activity. Do this. Try to get all 5 things done. See what you can do. Take a moment for it. So anyone notice the negative indexing? Who figured out what it did? No one figured it out? Let's try -2. What was printed out? Come on, this isn't a trick question. 2 from the end, there you go. -1 is you're indexing backwards. But be careful, it's not, there's no -0. I mean, that doesn't make any sense, right? But it actually counts backwards, which is kind of neat. Or indexes from the other end. Now be warned, this is a Python thing. There might be other languages that do it as well, but it's not particularly common among the big popular languages. So just be aware of that, but it's kind of a cool thing you can do in Python. Who here saw how to get the length of a string? It's kind of hard, it's just this. That's what you were saying, right? Yeah. Oop, except you print, not pring. You can ask a string, like, well, how long are you? Well, there's 13. What's 13 what? Well, 13 characters. But, okay, there's 13 characters in the string. What's the last index then? What's the last valid index in this string? 13? Makes sense, right? There's 13 characters. Give me some string at index, 13. String index out of range. There's 12. 12 is the exclamation point, the same as the -1. And if this isn't clear to you, remember, 0 is an index of one of those characters. So there's, if I had the string hello, oops, obviously not going to work. There are 5 characters in there, but what are their indices? 0, 1, 2, 3, 4. That's all 5 characters. We count the 0, so be aware of that. Anyone try this? What did this do? Yeah. I'm going to go back to the longer string. Get rid of this. I'm going to say 0 through 5. Hello. It'll give you all characters from index 0 up to, but excluding 5. So it gave us 0, 1, 2, 3, 4. Yeah. Sorry, you have to speak up. I can't hear you.
I'm having the issue with that, saying that A isn't defined.
A is not defined. Sounds like you've got an A in there that, is it supposed to be a string? Make sure it's in quotes. It would be hard to see, but I wouldn't be able to get tongue-tied here. I don't know based on that. Sometimes it's easy for me to know, but that's a tricky one. See if you can figure it out. You figured it out? Awesome. Now, a neat thing to note is if you want to start at the beginning, you actually don't need to specify the starting index. You can just leave it blank. It'll assume it's the beginning. Similarly, if I said 5, go to 5 to this, it means go from index 5 all the way to the end. There's also a neat one too. I could say 5 to 10, but 2. This means go from index 5 up to, but excluding index 10, but every other index, which is kind of neat. Now, to be clear, this is a neat thing. I think I've used it in practice. I could count on one hand. But every time I get to do it, I'm always really excited because I'm like, sick. I get to go do that cool thing because you never really get to do it. But it's there. The place where this does come in handy is, what if I want to count in reverse? What if I want to go from index 10 to index 5? Well, it's going to print nothing out because it's going to go, okay, start at index 10 and go to index 5. Well, what comes after 10? 11, 12, 13, 14, 15. Am I ever going to get to index 5? No. I can't. Because the default is, well, you count by 1. Well, if I want to go that way, I have to count by negative 1s. There. So this is the place where, like, this is the use case a lot of people will see more often. If you ever want to, like, count in another direction. Anyways, we'll wrap up here for today. Cool. Remember, if anyone has any questions, thought, concerns, they want to chat, come to student hours. It's woefully underused. I get lonely. It's boring.